I'm going to tell you an interesting story that took place all the way back during the 20th century BC in Greece. Now, the story goes like this. There was a farmer who was grazing his cattle and sheep. Now, while grazing his cattle, he somehow stumbled upon a rock. Now, when he stumbled upon a rock, he found that the nails in his shoes and the tip of his stick got stuck to that particular rock. Now, the rock was somewhat black in color. Now, the farmer was intrigued. The farmer was intrigued because he found that there was nobody pulling him, yet the stick as well as his shoes were stuck to the rock. So he dug out the entire rock and he found that it had the property of attracting certain objects. Now, the name of this farmer was Magnus, and he hailed from a region known as Magnesia in Greece. So, after the name of the place, the farmer named that particular rock the black rock, which had the property of attracting certain objects, as magnetite. He named the rock as magnetite. Now, he found that this rock has certain properties by which it could attract certain other substances. But for a long, long time, nobody conducted any studies on magnetite. It was sometime during the 6th century BC, that another philosopher, Thales of Miletus, conducted more experiments. Now, he found that magnetite had a natural property of attracting these certain substances when placed near them, unlike amber. If amber has to attract those certain other substances, amber has to be rubbed. But Thales of Miletus found that magnetite need not be rubbed against any other substance. It has a natural property of attracting these certain substances. So thus, magnetism was discovered. Now, magnets or magnetism was discovered in the 6th century BC in Greece. Sometime during 5th century BC, there was an Indian philosopher and doctor called Sushruta. Now, Sushruta believed that magnets and magnetism has healing powers. And people during that time in India believed that magnets could actually heal ailments or cure ailments. So, Sushruta often in his practices used magnets and the properties of magnetism in order to cure his patients. Now, magnets were not restricted to medical purposes alone. Even Archimedes, the great Greek philosopher, used magnets. Now, you will be surprised to learn about the purpose which he used magnets for. The purpose which he used magnets for was warfare. Or, in other words, he had found out that magnets are able to attract iron nails. So, what he did was he used these magnets to pull out iron nails from enemy ships. Now, the moment iron nails are pulled out from enemy ships, the ship's body becomes unstable, and obviously, when the ship sets sail, the ship will sink. So, this was how Archimedes used magnets for such a mischievous purpose, yet a very practical purpose in warfare. Now, magnets also had a vast application in navigation. The Chinese used magnets for navigation because they had also found out another interesting property. The property was that when a magnet is suspended freely from a string from a fixed support, the Chinese discovered that the magnet always aligns itself in a particular direction. And due to this alignment, they were able to say in which they were navigating. So, why do you think that when a magnet is suspended, there is an alignment that takes place? Let us find out. So, experimentally, it has been found out that a magnet consists of what we call two poles. It consists of a north pole as well as a south pole. So experimentally it has been found out that there are two poles that exist in a magnet. Now just like we saw in the case of electric charges where like charges repel one another, even in this case like poles repel one another. As you can see, a north pole when brought near the north pole of another magnet are repelling one another. Similarly, when the south pole of one magnet is brought near the south pole of another magnet, because they are like poles, they repel one another. And as you can see, unlike poles, that is, when a north pole is brought near south pole, they attract one another. So now let us get to the reason why a magnet always aligned itself in a particular direction when suspended. Now this man you see in the picture is known as William Gilbert. Now William Gilbert was a very famous scientist sometime during the year 1600 AD. It was during that year that William Gilbert conducted various experiments. And through these experiments, he found that the earth itself behaves like a huge magnet. Or in other words, he concluded that it is as if there is a huge magnet that is buried inside the earth's surface. So how does this explain what the Chinese used earlier? If you consider this picture, over here you will find that a magnet has been placed along Earth. Now William Gilbert proposed that the Earth behaves as if it has a magnet inside it. But you will notice that this magnet is inverted. What I mean to say is, the north pole of the magnet is near the south pole of the Earth, that is the geographic south pole. And the south pole of the magnet is at the north pole or the geographic north pole of the Earth. Now let's say we have a compass. Now a compass is a very simple instrument which contains a needle with one portion marked out in red. That red portion of the compass corresponds to the north pole of the magnet inside the compass. That is, a compass needle is also a magnet. Now this red part corresponds to the north pole of that magnet. Now what do you think will happen when this compass is placed somewhere on the surface of the earth? This north pole will be attracted by the earth's south pole, and thus this compass will be pointing towards the geographic north pole. Similarly, the other end of the compass that is not marked in red will be pointing towards the geographic south pole or the magnetic north pole. So using this property, the Chinese were able to discover the north whenever they were navigating, because they found that whenever a magnet is suspended, the north pole of that magnet always aligned itself with the south pole of the Earth's magnet, because unlike poles attract, and since the south pole of the Earth's magnet corresponds with the geographic north pole, the Chinese were able to navigate very easily. Now let me tell you an interesting fact about magnets. Now we have seen in electric charges that we can obtain a single positive charge or a single negative charge, because we know that protons exist which are positively charged as well as electrons which are negatively charged. But in the case of magnets, it is impossible to obtain monopoles. What I mean to say is, we cannot obtain an isolated north pole or an isolated south pole. Whenever we break magnets into smaller and smaller pieces, we will find that these small pieces also have a north pole and a south pole. As you can see in this animation, at first we break them into two pieces, and then these two pieces into further two smaller pieces. As you can see, we are unable to get a monopole, because magnets do not exist in monopoles, that is north or south alone. They always have a north as well as a south. Now consider breaking a magnet to its absolute basic unit. Now since magnet is also matter, its basic unit will be an electron that is contained in an atom. Now even this electron does not exist as a monopole. When the electrons are rotating, or revolving inside an atom, they also contain a north pole as well as a south pole associated with them. So we can see clearly that even if we go to the basic unit of matter, we are unable to get the existence of an individual north or an individual south pole. So we read and studied a lot about magnets. Now it is important to know that magnets have a wide variety of applications in day-to-day lives. And magnets come in various shapes and sizes with which they aid us in certain activities. In this picture, you find three kinds of magnets that are commonly used. A bar magnet, which looks like this, a horseshoe magnet, which, as the name suggests, looks like a horseshoe, and a ring magnet, which again, as the name suggests, looks like a ring. So summing up, we learned that magnets contain two poles as experimentally found, a north pole and a south pole. Just like charges, where opposite charges attract and like charges repel, even in the case of magnets, opposite poles attract and same poles repel. North-north will repel, south-south will repel, but north-south will attract. We further found out that magnetic poles cannot exist as monopoles. It is impossible to get a single north or a single south pole. We saw that even if we break down a magnet to its absolute fundamental unit, an electron, even there the existence of north and south will be together.